We want to find an exponential function through the points 125 and negative 1, 5. So first thing we'll do is we'll start off with a basic exponential function. Y equals AB raised to the x power, where x and y are our input and output. So these are our x and y points here. And depending on your points, this might be done in different ways, but I notice I have a point 1, 25 here. So when x is 1, y has to be 25. So I'm going to start with that point. So y has to be 25 when x is 1. So that means I got 25 equals a times b. Now I have an equation here, but it has two variables. So I'm going to need a second equation. So I'm going to use the second point and do the exact same thing. So when y is 5, then I have a, b, and now b is being raised to the negative 1. And there's a couple different ways we can go about solving this. One common way that you'll see is, and the reason I wrote them above each other, is I can divide the two equations. I'll show you two ways in this one. You can decide what you like better. Because what's nice is if I divide the two equations, I get 25 divided by 5, which is 5. But here the a's cancel. And then when I divide two things of the same base, their exponents subtract. So I get 1 minus a negative 1, or equals b squared. Okay? So now I'm going to have my value for b by taking the square root, or because it's going to be an exponential function, I like raising it to the 1/2 power. So 5 to the 1/2, and that is my b. So here's where we're at. We have y equals a times 5 to the 1/2 power to the x, or if we want to have a little bit cleaner way of writing this, an exponent to an exponent, they multiply, we could write that as a times 5 to the x over 2. Now we do still need our value for a, and that's going to come from plugging in either one of these points. So I'm going to choose the first one just because I want to deal with the positive exponent, but it really doesn't matter. You're going to get the same value either way. I'm going to do something very similar to what I did the first time. I'm going to stick in the 25 for y, a, and then 5, and now putting in 1 for x. 5 to the 1/2, and I have something I can solve for a. So let's talk about what this is going to look like, because I'm going to divide by 5 to the 1/2. Yes, you could find that as a decimal, but I think it's better to keep things as exact numbers, especially with exponential functions. All right. Now the question may be, well, geez, how are we going to simplify this? Well, here we can use the fact that 25 is actually 5 squared, and this is 5 to the 1/2, and this is our a value. And what do we just say? If we divide two things of the same base, their exponents subtract. So 2 minus a half, and I'll just kind of do this over on the side. 2 minus 1/2, well, that's 4 halves minus 1/2, or 3 halves. So my a value is going to equal 5 to the 3 halves. Now that's not some nice number, but this is nice and exact. So I'm going to show you a couple ways we can write the final answer. And like I said, we're going to go through this that was more of an elimination way. We're going to go through it in a substitution way, and you can decide again what you like better. So 5 to the 3 halves times 5 to the x over 2. Because these things have the same base, there's several different ways we could write it. Of course, we could write it in terms of square roots. Here's one way. Again, this is the correct answer. This is our exponential function. We graph this, we will get what we're looking for, and we'll take a look at that as well. But one option is I could, 5 to the 3 halves. Well, that's 5 to the first times 5 to the 1/2, and then we've got times 5 to the x over 2. Well, 5 to the first is just 5. 5 to the 1/2 and 5 to the x over 2. Two things of the same base multiplied together, their exponents add. So we could write this as 5 to the x over 2 plus a half. And those already have a common denominator. So 5 times 5 to the x plus 1 over 2, which is a little cleaner. You can decide what method is best. If you wanted to write this in terms of square roots, we have a 5 cubed, which is 125. Taking the 1/2 power is the square root of that. So that would look like square root of 125. And if we go back to here, 5 to the 1/2 could have been written as square root of 5, so square root of 5 to the x. Both those are perfectly good options. So it's kind of up to you. Now let's verify our answer in Desmos, and then we'll look at some other options. So here, let's see, right about there. So we said, okay, how are we going to test this? Y equals 5 times 5 raised to the, with the way I have it, x plus 1 divided by 2. Now, remember our original problem. It said it had to go through -1, 5 and 1, 5. So let's look at our points here. There's -1, 5, so that checks. And our other point's going to be up here. We said we wanted to go through 1, 25. So 25 is, let's see, where is, there's 25. And there's our 125. We're not quite hitting, there it is. See it? 125. So we verified graphically about our answer. And like I said, if we wanted to rewrite it in that other form, let's make sure that that's okay. Square root of 125 times square root of 5. And then that raised to the x. Notice how the graph went a perfect copy of our graph. They're literally right on top of each other, see? They're the same graph. So both those answers will work. A little bonus content here. Let's just say we wanted to solve it a different route. And again, this is going to be kind of up to you. Remember where we were. We had the two equations. We had 25 equals AB, and we had 5 equals AB to the -1. That's from right here. Okay, so the other option would be to use substitution. So that would be solving one of the equations for a variable and then doing substitution. So what I might do, let's isolate the A here. So I'm going to divide by B to the -1. All right, so we got 5 over B to the -1, or A equals 5 times B, because B to the -1, that negative exponent means we can bring it up top. We're going to take that and plug it in over here. So I end up with 25 equals 5B times B, which will be a B squared. So I have 25 equals 5B squared. Divide both sides by 5. I end up with B squared equals 25 over 5, which is 5. And notice we get to this point right here. So we're going to get the same value for B, and then we would do the same thing that we did in the previous method to solve for A.